Okay,
Yes.
so today we are going to discuss how do we generally build intuitions in graph problems, first of all. Okay, and like what are the subtopics of graphs that are generally very important if you are like preparing for graph rounds or let's say DSA rounds in general. Okay, and if I talk about DSA rounds in general, graph is a very popular topic due to obvious reasons that graph is generally used to make a lot of data structures. For example, like many databases use graph algorithms for storing data. Like even you see the folder or the folder system that you use in your Windows or Mac, that also is based on a tree structure. Okay, apart from that, like if I talk about the real life applications of other graph algorithms, like for example when you are installing dependencies, okay, like you are installing packages, so packages have dependencies among themselves. Okay, so finding that order is done by topological sort. Okay, or let's say you are completing your syllabuses, so you have to do some chapters before some like chapters, right? So there is a dependency, so these things are solved using topological sort. Okay, apart from that, like very common example is that like maps or like any kind of maps, I would say software uses shortest path algorithm to find out the shortest path from your source to destination. Not exactly Dijkstra, but a modified version of Dijkstra, you can say. Okay, so these are the real life applications of graph algorithms, you can say. Okay, so today, in the first place, before I begin, like I would like to hear that what exact problems or like what are the majority problems that you people generally face while solving graph problems.
Strongly component वाला भी आप.
Okay, strongly connected component. Okay, I think that's a bit advanced topic, but yeah, got it. Any other doubts?
Yeah, so I'm not able to come with a particular what is question is from particular topic. So
Okay,
I've
so
practiced a lot of problem, but मैं ये पता नहीं लगा के पाता हूँ कि what is the topic what question is the problem is asked.
like what should be the like graph का problem समझ में आ जाता है, like but you don't know what algorithm exactly you have to use.
So voice is actually breaking a lot.
Your voice just broke.
I said your voice is breaking.
Okay, am I audible right now?
Yes, you are.
Yeah, so can you just repeat what was your doubt?
I said whenever I try to attempt a graph problem,
Hmm?
I get lost because in which topic am I solving? So I'm not able to come up with
Got
like
it, got it,
particular
got it.
idea like
So how do you
which topic is
divide
needed
into
for.
subtopics of graph? Okay, like what exact algorithm you have to use, that part, right?
Right.
Okay, any other doubts? Okay, we will start. So first of all, like there are, if I broadly categorize the graphs into subtopics, so there are traversal algorithms. Okay, like there are traversal algos, and in traversal algos you have DFS, you have BFS. Okay, then you have shortest path algorithms. Okay, the first one is 0 1. The first one is normal BFS. This one only. Okay, the second one is 0 1 BFS. The third one is Dijkstra. Okay, then you have the MST algorithms. First one is Prims, which is very close to Daxa, like they use the same concept. Okay, and then there is, I would say, one more Krushkov's. Then you have the Topo sort, uh, and then you have the cycle algorithms. Okay, there are some algorithms regarding bridges and all of those as well, but I think that's not really important from the I would say if you're preparing. Is my voice breaking?
No, it's clear.
Okay, great. Cool. I think Siddhant, it's a bit of problem from your part, I guess. Then, yeah. So then you have the cycle algos. Okay, like so majorly, if you are just focusing for the interview part, to be very honest, like what you can do here is that, or let's if you are preparing to get good in DSA. First of all, let's discuss how can you determine whether you should use DFS or BFS for the first part, the traversal algos. Okay. So let's say wherever you see that you need to use a shortest path, or let's say you need to reach using the minimum time or minimum resources. Okay, like wherever you see that you need to use the minimum resources or something related to minimum is there. Okay, like you need to reach from source to destination in the minimum time, or let's say in the using the minimum fuel, or let's say using the minimum edges. Okay, whenever you want to reach the destination fastest, at that time you have to use BFS. Okay, so BFS is for speed. Okay, like remember in this way that whenever you need speed, you should use BFS. BFS is for speed. Okay, now when you don't need speed, okay, so let's say there is a tree. When you see that your answer depends on your children's answer, okay, when the node's answer, or let's say you are calculating some value for this node, okay, or let's say you are calculating the size of the subtree for this node, okay, whenever you see that to calculate the node value, you you are dependent on the values of the child. Okay, in this case it's most probably DFS. Okay, when you are dependent on your children, when you are dependent on the children of the node, use DFS in most of the cases. Okay, so that's the intuition by which you can decide that whether it's BFS or DFS. Okay, when you need speed, so I would just summarize. When you need speed, generally it's BFS. When you see that I need the data of or the value of children, or my answer depends on the children of that node, so it's generally DFS. Okay, clear till here?
GB.
Okay, so next if I see the shortest path algorithms, like shortest path algorithms are very important and it's very popular as well. Okay, the reason behind that as I told, shortest path algorithms has a lot of real life applications as well. Like Uber uses map applications, any kind of delivery systems uses a map application. Okay, so and in map applications you generally need an idea of shortest path algorithms. Okay, so there are three major categories: BFS, 01 BFS, and Dijkstra. Okay, so the first point is that like when you use BFS, when you use 01, when is Dijkstra. Okay, and remember one thing, you have to use the most efficient algorithm in shortest path. Okay, so let's say there is a problem which can be solved using Dijkstra, which can be solved using 01 BFS, which can be solved using BFS. Okay, in that case you have to use BFS, not the other two. Okay, if you use the other two you might not get through because of the obvious reason, these two has a higher time complexity than BFS. Okay, so whenever you have the option of using all three or multiple shortest path algorithms, you have to use the one which has the least time complexity. Okay, so I will just go through quickly of the conditions of them. So in BFS the graph has to be unweighted and it has to be it has to be unweighted. Okay, in 01 BFS weights can be 0 or 1. Okay, or it can be A or B. Okay, like there can be only two types of weight, like either it's A or it's B. Okay, now Dijkstra, it can be weighted. Okay, but the catch here is that it you can't have cycles, negative cycles. Okay, so whenever you see that I have a graph which is unweighted, in the first place think of BFS. Whenever you see unweighted graphs, whenever you see that the edges are of same weight, so unweighted doesn't mean always that it will not have weights. Okay, unweighted can also be like this, all edges have same weight. Okay, so BFS will work when the graph is unweighted or all the edges have the same weight. Okay, so whenever you see that all the edges have the exact same weight or the edges doesn't have any weight, think of BFS. It will be done using BFS. Okay, now coming to the second part, 0 and BFS. Whenever you see there are two kind of edges. Okay, like in 0 and BFS there are two kind of edges generally. Okay, like let's see, it can be written in the statement like this, that there is a red edge, there is a blue edge, or there is a red edge, there is a black edge. Okay, or it can be something like this. You need, like, I would give a real life or a problem statement that to travel through some roads you don't need to pay toll tax, to travel through some roads you need to pay toll tax. Okay, so there are two kind of edges here, the roads where you need to pay toll tax, there are roads where you don't need to pay toll tax. Okay, so the roads where you don't need to pay toll tax, it's of weight 0, where you need to pay, it's of weight 1. Okay, so in these kind of questions where you see there are two kind of edges. Okay, like one which is which has some value or which is weighted, and the other one which doesn't have any value and which is non-weighted. Okay, whenever you see there are only two kind of edges, think of 0 1 BFS. Okay, now in the third part where you see that there are weights in the edge. Okay, like there are plenty of different kind of weights, like every edge has a different weight. Okay, so for example, this edge has a weight of A, this edge has a weight of B, this edge has a weight of C, another edge has a weight of D. Okay, so whenever you see that there are different kind of weights in a in a graph. Okay, and these weights like A, B, C, D are all positive. Okay, like A, B, C, D are all greater than equals to 0. Okay, whenever you see there are different kind of weights and all of them are positive, then I would say it's the extra time. Okay, but one thing you must have realized till now, that Dijkstra will also work in problems where you can use 0 on BFS, and it will also work for unweighted edges as well. Okay, but you shouldn't use in these two cases Dijkstra. Okay, because Dijkstra has a higher time complexity, it will be a red flag. Clear till here? Hello. Okay, so use Dijkstra only when there are different or unique kind of edges. Use 0 1 BFS only when there are two kind of edges, and when the graph is unweighted or every edge has a same weight, use simple BFS. Because the time complexity here is V plus E, here it's also V plus E, but it has a higher time complexity because you are using DQ here. Okay, like in the implementation, when you see the implementation, you are using DQ, so it uses a higher constant multiplier. Okay, so first choice is BFS, then you look for 0 1 BFS, then you look for Dijkstra. Okay, this is the order you should be experimenting while looking for shortest path algorithms. Clear, like the order and when you should use all of them? Hello.
Yes, Anish.
Other people? Nitesh, Tarun. Yeah, Tarun
Yes.
has a question. How about?
No, sir. No questions.
Okay, cool. ठीक है, तो next we come to MST. Okay, like when to use MST algorithms. Okay, so this is a general advice as well. Like, first understand what's the use of a particular algorithm. Okay, like what do you mean by minimum spanning tree? Okay, so let's say you are given a graph. The goal of a minimum spanning tree is to traverse through all the nodes. Okay, or like uh, at least cover all the nodes. Okay, like let's say you are in a country. Okay, now as a tourist your goal is to visit all the cities, right? So let's say the country has this many cities. Okay. So what's the shortest path you can follow so that you cover all the cities? Okay. So the minimum spanning tree aims to cover all the nodes using the shortest path. Okay. This is the goal of the algorithm. Okay. So whenever you see there is a problem that you need to cover all the nodes, okay, or let's say you need to traverse to all the nodes, simply think of a MST algorithm, okay. And in MST you just need to learn Prim's algorithm because it's very similar to Dijkstra. So once you learn Dijkstra, Prim's will hardly take an hour or a two to understand and implement, okay. So the intuition behind MST problems is that whenever you see there is a graph, okay, you see there is a graph, your job is to traverse all the nodes using the shortest path. Okay. So the problem statement can look like this, that uh, there is a traveler, he wants to visit all the cities, or let's say you are driving, you want to visit all the cities and use the minimum fuel. Okay. Or it can be also similar to this, that uh, you have, let's say, computers. Okay, there are computers, each computer is connected to some other computer using edges. Okay, like let's say these nodes are computers and the edges represents that these computers are connected. Okay, so find the minimum length of the cables to connect all the computers. Okay, something like this. Okay, so essay questions like you will get when you need to use minimum spanning tree. So it's very simple. If I talk in layman terms, सबसे कम resources use करके, like how can I cover all the nodes? Like how can I cover everything using the minimum resources or using the minimum path? मेरे को सब कुछ लेना है using the minimum resources. ऐसे फील आना चाहिए प्रॉब्लम से. ओके. Any questions on MST? Okay, so सिद्धार्थ का जो प्रॉब्लम था, सिद्धार्थ आर यू स्टिल देयर?
Yes, sir.
तो ऐसे करके लाइक यू कैन डिसाइड कि when you have to use which algorithms in graphs. Okay, like when you feel that कि सब कुछ मेरे को cover करना है using the shortest path, it's most probably a MST problem. Okay, whenever you see that I have to reach from a source to a destination using the shortest path, you have to use one of the shortest path algorithms. And which one you have to use, that you can decide seeing the edge natures, the nature of the edges. Okay, तो ऐसे लाइक ऑब्जर्वेशंस बना के लाइक यू कैन कीप ऑन डिसाइडिंग कि कौन सा एल्गोरिदम ग्राफ का यूज होगा. ओके. नाउ कमिंग टू द नेक्स्ट पार्ट इज टोपोसॉर्ट. ओके. द बेस्ट पार्ट अबाउट टोपोसॉर्ट इज देयर आर नॉट मच वेरिएशंस. ओके, लाइक इन MST टोपोसॉर्ट ज़्यादा वेरिएशंस नहीं है क्वेश्चंस का. ठीक है. सो टोपोसॉर्ट में देर इज ओनली वन काइंड ऑफ वेरिएशन. wherever you see there is a order, or wherever you see there is a schedule. Okay, so very common example of a schedule is connecting flights. Okay, so whenever you see that something or some state depends on another state. Okay, let's say you have to complete these two before completing this one. Okay, for example, let's say if you are traveling by a flight, so you have to take flight A, reach to a certain place, and from there you have to take flight B. Okay, so now flight B has a dependency on flight A. Okay, so now you can say that I can have two nodes, flight A and flight B. So flight B is dependent on A. Sorry, flight A is flight B is dependent on A. So I will have an arrow from A to B. Okay, so the first observation that should come to your mind, or the first intuition that you should see is that whether there is some order involved in the question, or I have to find some schedule or not. The third point is that whether there are dependencies on the nodes, okay, and is the dependencies acyclic, okay. Like let's say B is dependent on A, but flight B cannot be dependent on flight A back, okay. This is not possible, okay. So whenever you have a circular dependency, toposort will not be possible, okay. So that's a not a toposort question, then it's a different question, so of some other algorithm, okay. So first of all, there should be like the question should ask that you have to find some order, or the question should involve that you find the schedule or something like that. So then you first draw the nodes and then the edges, okay. Then you find out that whether there are dependencies like acyclic dependencies on the nodes or not. If there is a acyclic dependency, if you have to find the order, it's a 100% toposort question, okay. So if these three criteria match, okay, it's a 100% toposort question, okay. And the last part is cycle algorithms. So in cycle algorithms, just try to know the basics of cycle algorithms, like in a graph finding the shortest cycle or finding the largest cycle, something like that, okay. So that will be very, means that will be more than enough for cycle problems, okay. So major things or major subtopics that you should focus on is toposort in graphs, okay, shortest path in graphs, okay. These are the two very important subtopics in graphs, okay. Now coming to the part that how do you determine what will be a node and what will be a edge in a graph, okay. So this is the very basic part, that how do you make the graph before implementing any algorithm, okay. So how do you determine what are nodes and what are edges, okay. So very simple thing, whenever, like first try to understand what are the states in the question, okay. So whenever you see there is a state, so for example in connecting flights, so a flight is an object, a flight is a state, okay. So flights will be node here, okay. So nodes are generally objects involved in the question or states involved in the question, okay. When like objects, I have given an example, for example let's say connecting flights problem okay. So flights are the objects here, or let's say you can say the places are the objects here, okay. Like if flight A goes from X to Y, so X is a node, Y is a node, and since there is a flight from X to Y, there should be a edge from X to Y, okay. So the objects should be nodes, okay. And states, so let's say there is a question, let's say uh, you are given a number X, okay. So in one operation you can decrement X by 1, or you can make X into half, okay, like X by 2, okay. So in this case, can anyone tell me what will be the nodes? Hello.
X, yeah.
So one node will be X, another node will be X minus 1, another node will be X minus 2, okay. So here every state we are considering as a node, okay. And from X we can go to X minus 1, okay. So there will be an edge from X to X minus 1, okay. So here we are making every state as a node, okay. So nodes will be either states or objects, okay. So this is by 2, yeah. Now what will be edges, okay. So edges are basically relations between nodes, okay. So let's say if there are two nodes, if you see that there is a direct relation between node A and B, you can simply connect it, okay. For example in this problem I told that I can decrease decrease X to X minus 1 and decrease X to X by 2, okay. So there is a direct relation from X to X minus 1, and there is a direct relation from X to X by 2. So when there is a direct relation between two nodes, or you can reach from a certain node to another node in one step, there should be an edge between those two nodes, okay. So if there is a direct relation between two nodes, you should have an edge. Now how to determine whether it will be a directed edge or a undirected edge? How do you determine? So let's say if the relation is from A to B, it will be directed. If the relation is A to B as well as B to A, okay, in that case it will be a undirected edge. Okay, so for example in this question, x we can decrement x to x minus 1, and we can make x to x by 2. Okay, so tell me whether it will be a directed edge or an undirected edge. Come on guys, so 14 people are there. So here is the edges will be directed or undirected? Tarun,
Directed, sir.
Nitesh. Yeah, directed. And the reason for that is you can go from x to x minus 1, but you can't come back from x to x minus 1 to x. Okay.
Yes,
So
sir.
so whenever you see that I can go from A to B, and I can also come back from B to A, so there will be an undirected edge in that case. But when you see that I can go from A to B but I can't come back from B to A, it will be a directed edge. For example, let's say if I say that I have a place called X, I have a place called Y, okay, and there are flights between X to Y, okay, so in this case it will be a undirected edge because I can go from X to Y and also can come back from Y to X. Okay. So whenever you see that I can go forward and come back, it should be undirected. If you see that I can only go forward and never come back, it should be a directed edge. As simple as that. Okay. Clear? How do you make the nodes? How do you determine the nature of the edges? How do you determine what algos you generally have to use? Okay. Any questions? तरुण ग्राफ का प्रॉब्लम्स में कोई क्वेश्चन है? साक्षी, शुभम, सिद्धार्थ, नितेश, राहुल. I think Rahul, did you start graphs now? I think you are still doing recursion, right? Okay, Tarun doesn't have a question. Okay, so if others doesn't have a question, so we can call it a day. But make sure that you put a lot of focus on graphs, because graphs is a very important topic if you want to be a good software engineer as well. Okay, so try to complete the problems and the problem sheets I have put from the lead code, and the lists I have given you of lead code problems. Okay, so I think that's it for this session. I have recorded it, so people who couldn't see it from the beginning till the end, so just go to the recordings and watch it once more, so that if you have missed anything, just you can watch it and learn about that. Okay, so if anyone doesn't have any other question, we can end.
Anish, these algorithms are asked directly also in the interview to implement. Let's say someone says, "Can you implement extra and explain all
No,
this
no,
with
no. I don't
job
think.
method and all
No,
that?"
no.
Yeah.
It will not be directed. It will be a question with a use case, and you have to implement that algorithm and solve that problem.
I mean, the algorithm itself takes some time to
Yeah.
so
So
sufficient
first,
time
yeah,
during it.
first part is like you learn the algorithms, you directly implement it. Okay, and then you start solving problems on that algorithm. Okay.
Right.
So it's a stepwise again. So that's why I have also put in resources for learning particular algorithms as well.
Oh, got it. Thanks.
Cool. Then happy weekend, everyone. Bye.